Hi, Mr. Hook. Welcome. That didn't take you very long, but you're sitting in front of the computer just waiting. Didn't take you very long at all. Tim, DJ, Gustavo, Richard Becker, Ace, Piston, Peter, Crystal. Alrighty. I'll give a few more seconds, maybe. Wait for the crew to turn up. It's a little bit early for some of the people in the United States, but perfectly good time for those in Europe. Not to mention those in Australia having a bit of a late night, doing nothing. Alright. Anyway. Okay, so what we're going to be doing is I need to test some more modifications that I've made with the FLIR 1 Pro software that I've been writing. And because I'm writing this for the purpose of doing board diagnostics, then I obviously want to test to see if it works. And one of the tests I have is that I take a good wholesome 8203115 board, which is from an A1278. It's one of the good boards that they produce. And I'm going to deliberately put some short circuits on it and see what happens. Now there's two types of short circuits I want to see. One is just a straight out short constantly, say like on PV bus G3 hot or something like that. And the other one is what I call a heartbeat short. And a heartbeat short is a sort of short that it won't show up on your power supply too much because the power supply doesn't react fast enough. But when you do catch it, using isopropylene alcohol or something like that, it's a pulse that just keeps happening. And so the heat up of the capacitor or whatever the short is very quick. And so you don't see the current spike on the power supply. So I'm hoping that maybe the thermal camera will pick it up. So I guess the only way I'm going to find out is to deliberately mangle this poor board up and see what happens. So I think we'll start with the 3V G3 hot short or something like that. I'm kind of worried that I might make the short a little bit too intense and do some damage, but yeah. I mean, I do like the 3115s, but I also have a hell of a lot of them sitting around doing nothing. Okay, let's see. The Sinister, no, it's not a macro lens, this one, it's just a standard one. So if I'm just going to put it there. So like right now, obviously there's no power on this. The software modifications I've done, it's so that it has a limited palette range, so you don't have everything swamped out by the infrared. Like I can bring the infrared back. Let's see if I press the right keys, being in the right place might help. Still getting used to this, folks. Nope, wrong way. So like if I let it keep going, eventually this will become like fully saturated with all the noise of the infrared sensor. I can also change the opacity or the alpha level of the, and that is not the right key for that. What do I use? Oh yeah. So let's see. So like that's full alpha, so we're seeing absolutely nothing of the visual image. Should be able to see my fingerprints remain on the board. Yeah, to a slight degree. Let's see now, hopefully okay, and then we take it all the way back, or we can go all the way to 0, which is kind of pointless because we can't see any of our infrared image there. So we'll bring it up to about halfway. And then we'll reduce that palette. Damn, now I'm forgetting my own stuff. Oh yeah. Nope. How can I forget my own key combos? This is terrible. Oh yeah, that's right. The reason why we just only are interested in the top portion of the temperature sensing range. Short the MOSFET, inject 20 volt into PP bus. Yeah, the MOSFET's a bit of a overkill. I want to go for a resistor or a cap. So, alright, so I'm going to have to get this camera out of the way and get back to just a normal overhead. I'll find a better way of placing this camera later. For now, I'm just going to have to keep it on this tripod and put it off to the side somewhere. Hey, John Vin. Hey, Gus and Ali from Maldives. Tom. Okay. Yeah, I gotta work out which one I want to short. Let's see. PPBus G3 Hot would be a good option. Yeah. Choices. Yeah, Jim, hopefully that cable, it probably won't be here for a week or two though, no my luck. So the other risk I've got is I'll just blow the fuse on the short. Damn, I didn't check to see if the microscope camera was alive. And it's not. Hallelujah. Okay, please stand by. Come on, you mangy bugger. Come on up. No? It's getting to the point now where there's so many cameras and accessories, all sorts of things attached to this workstation that it can get pretty tricky to remember that everything... There we go. We're live. Yeah, it can get quite tricky to remember where everything's meant to go and what it's meant to do. Andrew Hughes. Okay, there's a couple of caps by the SMC. Okay, I think this one here, we'll give that a shot at shorting that out. Now to short it out, what I'll do is I'll put something like a 3 ohm resistor or something over it. That should give us a moderate amount of heat without completely killing it. So we've got some YouTube data feed rate issues. 402, well, you're a little bit too small. You're gonna fry in an instant. Oh well, guess we'll find out, eh? Let's see. Finally, a use for the useless book of parts that I have. Or part books, whatever you want to call them. Okay, you guys are 402s. We'll start out with, say, a 5 ohm unit. So 5 ohms, you put 5 volts into it, you'll get an amp, which will give you 5 watts, which is more than ample. It also might go piffed and die. Oh shoot, well I got about 3 or 4 of them there. Welcome to why I do not like these component books anymore. At least not this particular brand of them. No name brand. You try to get one out and a million come out, and I'm fairly sure I've had an occurrence where they actually do not have the correct value in there. Okay, so we're going to put that on top of there. But first we'll have to clear away, which means I need to stick this in between these two caps so I don't lose it, which means I'm going to lose it. Hey Margarita, just noticed you were there. Gary Hampson, I'm using a photographic one with an adjustable color and brightness. I sort of set it to 4200 Kelvin and maximum brightness. It's probably a little bit small. I could do with another. I could do with some bigger ones, but for now it's low on the list of things that must be done. Got more essential things to deal with, like programming software that other people can end up using. Too much work with Open Boardview 820000165. So what, you've been having a win with it, or not sure how to translate that in terms of Open Boardview being too difficult or Open Boardview making you money. Hey Kurt, Cinco. It's actually surprisingly difficult to make a nice short that's going to get warm and not kill things. Because if you make it just a 0 ohm resistor, you're probably not going to get a lot of heat out of that. Because you need the resistance to make the heat. Which is why when you get a really hard short, it's quite difficult to locate it. Oh man. Yep, that resistor's gone. Or maybe this is it. Is this a resistor or a piece of fluff? Oh, it's a resistor. Some flux might help. Hey Kurt, well, we're just going to simulate a failing board from a short, couple of different types of shorts. Oh, no wonder that's not melting. That's only on. Oh, damn you, Quick. If there's one thing I don't like about the Quick, it's the fact that you can't change your channel, as in your settings, while the handle is in the holder. Yeah, I think thick wires are probably a little bit too excessive. Okay, we're just going to see if we do have indeed a 5 ohm or so. Okay, so we've got 5.3. By the way, I think, I was noticing that the stream seems to be a little bit better. I don't think it was the buffering. I think what the difference was is that I did not have the in the 6th generation Intel CPUs and greater, they have a little bit of circuitry or a little bit of functionality that allows video streams to be encoded a bit better, or at least a bit faster with lower CPU. And I realized that I didn't have that module loaded because I just updated my system from 1904 to 1910 to 24. And so that dropped out, so it's actually reverting back to full CPU rendering now. So my load is a bit higher, but the clarity ended up being better. Alright, okay, so that's 5 ohms, and I've just realized now that these require a DC inboard. Let's see. Something is in that fan assembly and I don't know what the heck it is. There's something up in the top section that I'm going to have a look at. Honestly, it sounds like someone pegged a playing card onto their bicycle wheel. that rattling noise it makes. Alright, hopefully I've got the right one there. And I also need to change what MagSafe cable I use, because this will be a MagSafe 1. And most of the things I do now are MagSafe 2, but we do occasionally get the MagSafe 1. Let's switch this over. So where was our short? Somewhere around about here. This could well go pop before I even get a chance, so I'm going to switch over to infrared. And I can see we've got a little bit too much of that bleeding. Okay. The reason why it's showing up a bit warm up here is from where the hot air was. Alright, let's see how we go. Yeah. I'll just turn it off up there first. Okay, on. This may or may not be spectacular. Here we go. Great. Short's not showing up, everything else is going, so 5 ohms is obviously not enough to make it upset. Maybe we do have to go for a hard blob. Damn. The disappointment is real. Unbelievable. You call yourself a short? How lame. Give it 240. Rightio. Pedro's here to try and destroy my business. Maybe it actually wasn't even connected properly. No, it was, because we measured 5 ohms. I suppose the other way we could do is deliberately try and crack this capacitor. Yeah, destroying the motherboard is probably not the best option. This is why you should always keep your shorted caps, folks, so you can always use them later. Because that's what we all want to do, right? Where's my sample wire? Somebody cleaned up their office. Alright, this is 1.5 ohms. So no, maybe we'll get lucky this time. I'm being a little more careful because this rail can deliver a lot of power. So maybe I should have just gone straight for the heartbeat rails where I know that they're not going to be, they can shut down before they actually burn out. Hey James, does this software compare? No, Sam, no, nothing like that. Nothing that fancy. Good God, no. We're using wetware to make that determination. I wonder if anyone knows what wetware is. Really could do with more light though. Oh well. Yeah, so here we go. Although it's kind of cooked up already still. No, it's still powering through that short. That's hilarious. Although it has lost all its power now. Come on. Little bugger. It does not want to do the short. Alright, anyone want to make a suggestion on where to put a short? Because it's not playing the game here. Yes, it is turning into a lengthy short. Pun pun. Fine. I'll do the heartbeat one then. LCD backlight. The only trouble is with LCD backlight is that I'll have to connect a screen, won't I? Because it will want to sense that there's something there before it will start driving it. Across the CPU caps. Okay, Christian, that's a little severe. Hey, Eric. Well, I was on G3 hot just then. That's what this was. And it didn't want to play ball. Alright, so there is the other one, which is the heartbeat one that I routinely encounter. And it's typically like this cap here, I'm pretty sure. Okay, that's a 5ES3, so that actually might have some potential for working for us. Yeah. Honestly, you try to deliberately break something, and nothing breaks. Maybe I'll just randomly spray solder paste on the board. Kurt, not really, no. At least I don't imagine so, no. I think when it comes to this sort of stuff and people are trying to pick out faults based on temperature signatures and current signatures and things like that, I mean, you can to a degree, but I think what happens there is that people start to rely on that a little too heavily, and then before you know it, they really, if it's not within the scope of what's expected, they just sort of like sit there and go, well, I don't know what's wrong. Yeah, so I'm not trying to, like I said, I'm not trying to do a perfect short because I do want about 2 or 3 ohms, which should generate a good couple of watts of heat. It's either that cap or that one of them around here. Not that one. Definitely not that one. I'll try that. Unfortunately, it's running a little cold a little hot now. Okay, now you may be wondering why all of a sudden the whole crap, wrong window. Well, you may be wondering why the whole lot is looking like it's warm. It's not. These maps are a relative temperature map. So what it does is it measures the whole frame and then it equalizes them around just so that it knows its range, and it adjusts it to be 0 to 255, and then it spreads the palette over that. So that's why when I spray it with something that's really cold, then relative to the cold spot, everything else seems effectively quite hot. So like that. But now, if our short works, we should hopefully see something come to life. But have I just killed this board completely? Alright, this might be working now. Pretty sure it's starting to warm up in that little short spot, which was right about there. No? You going to show up there, are you? That's no good. This is killing me. Talk about bad performance on my first day. Someone needs to send me a shorted board. What the heck? I'm trying to give it time. It's only showing 15 milliamps. Talk about disappointment. Lane port is shorted, thermal confirms. Yep, except it's not. By the way, the camera is seemingly upside down, I'm sorry. I just keep every time, no matter which way I put it, it's always backwards. But no, right, I'll fix it up. Just hang on there. Be prepared for a bit of horror here. And the reason why it all seems offset is because I've got the offset settings set so that it works for the distance that we're working on. And I've lost connection. That's half the reason why I hate shifting this thing around. Don't worry, we'll get it back in a second. Well, maybe not. What's going on? Damn the person that told me to flip it. Now I'm gonna have to travel overseas and flip them. Okay. And we're back. Let's see, let's catch up the questions here. Sorry. What resolution does the camera have? It's a 160 by 120. The actual visual camera is a 1440 by 1080. Wire up a lab supply directly to the board and crank it up until you get the heat. Yeah. That's the funny thing, you know, it's like I deliberately tried to break this and it's not broken. It's kind of like that when they tried to do the board at the Mac repair place, the Apple store. I shouldn't say Mac repair place. And they could not get it to stay broken. How disappointing. This is truly disappointing. Clearly, shorted capacitors have a very special behavior. Let's see. Need volts. Nah. I don't know what to think. .3. Yeah, I mean that should generate some. Damn stupid thing. Hey, Aussie Geek. Yeah, I might have to check one of the donor boards because this isn't playing. This is not playing the game. Let's see. It's annoying because I actually posted on the, what do you call it? Posted on the title that it would be deliberately breaking things, and I did, and it still wouldn't go into a short mode. So it's sorely very disappointing, and I'm not doing this actually for the YouTube video. I'm actually wanting to see if it can do what I'm hoping it would do. But it's just letting me down. Reverse polarity. Nope, no thanks. I mean, yeah, they'll cause some excitement, but so I don't want to actually destroy the boards. I just want to have a localized short circuit. I mean, is that so hard to do? It seems it is. Well, let's see how this one behaves. This one's supposedly got Thunderbolt issues, so I guess we'll see. They're not going to be short circuit related though. But we'll at least get to see the board warm up. I'll be very glad when the cable that I want arrives for this, because this is just madness. Alright, let's go to the view. Okay, that warmth, yep, that's just from hot air. And now we have to go back to MagSafe too, you mongrels. I wonder if what the problem was. Maybe my MagSafe was quitting out on me. I didn't think to check that. I mean, we weren't showing any green or anything though. Oh, well. Anyway, we'll go for a normal boot sequence here, hopefully. If the MagSafe actually sits on. Now, hopefully my viewport feature works. Yeah, cool, it does. It's a little bit jumpy though. Well, what the viewport thing does is it just clears away the infrared section layer, so you can actually see what it's looking at directly on the board. It's a bit hard to see because it's sitting on top of the heatsink, but anyway. Let's flip this over and see what it looks like. Would help if I didn't disconnect the MagSafe. You can see those RAM chips picked up pretty quick. This is a 3437, and that's why it's doing that pulsey thing. At least I'm pretty sure it's the 3437. Don't make a liar of me. Good, I certainly tried to delivery break it and it didn't play that game. I put a short on it, I put 3 shorts on it and it just kept going. So, yeah, so much for that. E. Daniel, no, I'm not from Ireland. Oh, a wholesome Australian person. Oh well, it's certainly working. I think I do need more light actually over the board so we can get a better picture on the camera. So we can actually see what we're looking at. Because otherwise, it's a bit too dark. Is the temp versus light range correlation adjustable? Richard Bicker, how do you mean by that? You mean the palette versus... I can adjust the palette. There's actually many different palettes I can use. I just happen to like this one. There's the alpha value, and the alpha value is sort of like how transparent the infrared layer is on top of the visual layer. But the visual layer, I've got no way of controlling that at this point. That's just a JPEG image that's sent through to the software from the camera. Get that alignment a bit better. Trevor Hold, take a hike. Haven't you been harassing me all day? Dark to bright over different temperatures. Well, Richard, I mean, that's what the coloration is. I mean, I could change the alpha over the range, but yeah. Yeah. Yeah, this sucks. I was really hoping for a short and don't have one. This really, really sucks. I don't know what else to suggest. I don't have anything to fix. No one sent anything today. Hey, Ned Beard. So close one hot zone to see another hot zone. Anyway. Yeah, because I brought it closer, I have to bloom and adjust the... Yeah, it's close enough. Nah, yeah. If it wasn't for the attitude, the other person was kind of right. This is boring, but I'm not sure what I'm going to do about fixing up that shortfall. No, well. Kurt, the easiest way is just tell them to just eliminate them. That's pretty much the only thing you can do, really. They don't respond to reason or anything like that. That guy, I'm pretty sure, has been dropping sort of passive-aggressive taunts on my chat all day. And this cable is really ticking me off. Because there's a USB-C camera, and we've got a USB-C to A adapter. And it's going off. This extension cable isn't much chop. But, yeah, I have spent the money to get a proper USB-C extension, Thunderbolt 3, and it's going to take a few days to arrive. Okay, that's crashed out again. It's not the software that's crashing, it's this connection that's causing the problem. Yeah, I would love to eat something right now, to be honest. Yeah. Do you think a macro ends would make it easier to focus on areas of the board? Not so sure, Tony W. I mean, I think I just need more light on the board. It is quite dim here to show things up. But I mean, with a true short, you'd at least get some idea fairly quickly. I'm going to get an iPhone board, see if that can provide us with any joy. I doubt it. Oh, do I have an iPhone 10 with a short? I wouldn't even know how to plug that thing back in anymore. Yeah. Boring. Kurt, it's my own software that I've written up. Yeah. I'll just switch back to overhead. It's HTTP. Have you had a chance to use the FLIR one with its native app? Maybe an idea of what it's capable of. Jonathan, I know what it's capable of. It's just a case of I'm trying to make it just fit this sort of scenario. I have seen them work with their native app. I've also seen it work with the other Linux app that someone else wrote, and then this one here that I'm just writing. I really do need more light on that visual side though. And most of the time, the FLIR stuff, they're usually all... Well, most of the infrared cameras are all ideally for more than a couple of meters away, because we're dealing with really close-up stuff here. What the heck? I've got an iPhone. What are you? You're an 8 Plus or 7 Plus. I don't remember having you in here. And yet here you are. Amazing when you find random bits and pieces floating around in your workshop that you had no idea you had, and it's a reasonable piece of gear. Seems like it's a hidden update on YouTube. I haven't... But... Yeah. Let's see what happens when I just plug this in. And the trouble is, every time you move the camera up and down or around, you have to readjust. You have to readjust your scale and things like that, because you've got two cameras slightly side by side, so you've got parallax error. And then you've got the problem of the fact that there's no real depth calculation. So when you scale for one particular depth within a 10-meter range, then that is not going to be suitable for at 1 meter range or a half-meter range. But as you get beyond 10 meters, it sort of like just tapers down or asymptotically approaches a fixed value. But close-up is not quite that. Close-up's harder. Ask Lewis to recommend bright light. Yeah, I saw he got his new one. Okay. See if anything comes up on this. For the most part, really, these cameras, you're really just looking to see what region the problem is in. Right now I've jinxed it. The reason why it's stuck up there is from reflections. That's where these cameras have some troubles with their radiosity effects. Let's try that. You can defeat it by doing that. Yep, nothing uniquely getting hot there, so that's not a problem, that one. Yeah, let's find another one. Emissivity, that's it. Interesting that it only is the very tip that's getting hot. Mind you, I can tell you that the rest of the shaft gets pretty damn hot too. Hey, see my Zaffa. How's it going? Nah. I've got to find something that's going to be shorted out. For goodness sake, how hard can this be? Maybe I should take a cap and actually break it. Physically break it. Where was that cap that I was looking at? Oh, 3X, this is for the Android. It's the USB-C interface. Yeah, you know what? We get something like a... What have I got here? Okay, 3437. This is the one that's got the EFI issue. Let's deliberately try and short one of these caps. Well, just take one off and put in its place something else. Who would have thought trying to break a board would be as hard as trying to fix them sometimes? Probably could have really got the heat onto that and made it pop itself, but I gotta tell you, making these tantalum caps go into a tantrum, it stinks, and I really don't like that. Okay, so that's a 1206 type footprint. 1206 resistors, low. I've got a few of those. Let's see. I can already smell one of those caps must have popped. Resistors, come on guys. Give me the goods. Oh wow. I'll put the resistors that I want at the very, very, very bottom of the stack. The stack is huge. So this is going to be a bit of a Principal Skinner event if I'm not careful. If you don't hear from me, well, you know what's happened. Okay, here we go. That was close. Let's see. Do you buy donors in bulk or one by one? It really depends on the day. Depends what I'm buying. 34, 37s, 165s, things like that. Yeah, I'll buy them in about packs of 5 or 6. 30 ohms, that's a little high. Would be a good test though to see if you could find something like a 30 ohm short. Yeah, let's give that actually a test. Because it's not uncommon to get something like 30 or 50 ohms, and it's not enough to really... it's not enough to get the isopropylene to boil off. Jumper wire is a little bit too much. Too aggressive. Yeah, Richard, 0 and you're right, 2 or 3 wasn't really working, but it should. But I don't know why it wasn't. Saying it should and being told by the universe that it doesn't, I guess that's the way it goes sometimes, eh? The macro lens definitely would be good for iPhones. I'll certainly agree to that. I really should have done that to this one board I've got over here. This is the one that's still, the one over there is still a bit faulty with the Thunderbolt lane issues. But instead, I'm sitting here and I'm gonna risk this one. I have to leave the heatsink off maybe, maybe not. Yeah, we'll see what happens. I'm just going to see if this actually even draws current first. Alright, yeah, that's got some heat. Wonder if it'll even show up in the right place though. Okay. Let's chill down that hot spot. Where are you? Right there. It's persistent, yeah. Yep. So free spray can't win. Alright, let's see how we go with this. I'm just going to plug it in, hope for the worst. And it most certainly has indeed found that resistor. So, it actually worked. Funnily enough, it's still booting. And the CPU just crapped its pants. Let's put a heatsink on it after it's destroyed it. I don't think we did. I think it just shut down things, and then because the resistor is in a place on the board where there's a massive amount of thermal capacity, transfer capacity, and the resistor is very small, it basically cools down very quickly relative to the CPU. So we're going to do it again, but with the heatsink on. And hopefully I didn't ruin too many things. Boom, 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 boom. Let's try it again. Yep, okay, no, I did find it. Let's see, I'm going to put my finger there. I was definitely not going for my finger. My finger being probably about 40 degrees in these gloves. So like if I turn off that, yeah. So it's definitely locating that short very quickly. So you can see where my finger was getting warm on the CPU. Okay, so turn it back on, and all of the other warm areas around here should fade out straight away. There we go. Yep. So that locates it very quickly. Hey, Buzzcola. Alrighty. So at least finally one of our tests worked. It took way too long. Why is it I imagine there's a ton of these expensive devices out there? People stop using a Mac after it broke. Yeah, quite popular. Tradie Trev, yes, back in the 1999, 2000 era when if you left a heat sink off your Athlon or you didn't put it on quite properly, then you're absolutely right. They would go pop bang very quickly. I'm kind of curious to see how long this goes for, but I'm thinking when it shuts down, it just yeah, so it just shut down then. Oh, it's starting again. It's having another shot. Cool. You have to learn the heat profile of various boards. I probably shouldn't have to. In most cases, unless you mean like the general running profile, as in what parts will be getting hot. In which case, yeah, fair enough. But if we've got a short, and let's see how much power that's actually producing. I'm going to see what voltage we're getting across that. So we know it's 30 ohms. So we can... What are our volts? 8.5 volts across 30 ohms. Shit. Can someone please be a human calculator and work that out in my head? P equals I squared R. So 30 ohms, 8 volts. It's roughly a quarter, 250 milliamps. So 0.25 times 0.25 is not a lot. Steve K, yes, I can put the temperature on there. I just haven't done it. There's still a lot more for me to write on this code. Like I'm probably going to have a sidebar on it. My mouse show up? Yeah. I'll probably have a sidebar coming down the side here, then pushing out, so it actually fills the frame up more, and that will have things like the temperature, the range, all sorts of things like that. Hey, Crazy J. But yeah, this is basically what I'm hoping for, is that when you get a proper short, it just shows up pretty much as a single point like that. It immediately takes you to where you want to go. I'll try and lift the board up. The limit on this is 15 centimeters, and I think we're at about 22 or so. And so I'll try to bring it up closer. It will technically go out of focus, but yeah. Let's see what we can do. I'll actually disable this for the moment so I can get a better alignment. Actually, no, that was... Scale's a little off. That's pretty good. That's close enough. Hey, Nelson. Alright, so let's plug it in again and see what happens. If we make it so that we show all of the heat map. Wrong way, Paul, wrong way. Okay, so this is just to demonstrate why the software is useful. Let's see, and I'll change the alpha all the way up to, how do I do that? Yeah. Okay, so that there is just purely the infrared. That's all that you'd be able to see under a normal infrared camera if it was like the Seek or the any of the others where they don't actually have a visual camera. It's just the sensor itself. That's what you would see. And so you would be able to work out roughly where things are. Be able to put a pointer on there and locate it like that. But by having the ability to reduce the spread of the temperature ranges that you're bothering to show, as well as the alpha. Yeah, so like we bring the alpha in like that, probably add a bit more, and then bring that right down. And so this way you get rid of all the interfering data, leaving you basically with what you're really after, which is a cross right on where the part is. And if you want to check where the part is, but it doesn't really show up so well on this, but yeah, you can have a look. There you go. I take the little center thing away, and what are you looking at? You're looking at the resistor that's faulty. Yeah. So it works. So that works for a constant short. I really want to be able to try and do a heartbeat short, and I'm trying to think what cap I can, or where I can do that. Hey, Warren Stamps. Say CPU, GPU is hottest, but you want to find the cracked cap. Richard Bicker, I'd say it'd be pretty unlikely that you'd get the scenario where you've got a cracked cap and the CPU still running. Interesting that I just did that flip over there. Clearly I've got bugs. But if that was the case, you could always mask off those areas that are interfering with cardboard, just like we did with that. Yeah. So I just use a piece of cardboard and mask off the area that's interfering with your readings, and yeah, there you go. Easy. But I'm particularly liking this, how that just immediately shows up that it's the resistor at fault. That's pretty good going. And I don't know how warm that is, so I'm now going to go and use my little pinky finger and put my finger on that. If I scream, you know it's hot. If I don't, you know it's not. It's hot. I didn't scream though. Yeah, that's pretty warm. Made me jump, damn it. Do you have any videos of the code you wrote the software in? The Liam, I don't have any videos for this one, I'm sorry. I was thinking of it, but I was always too tired when I was doing it to have a chat and code at the same time. And particularly with this, I was going through a lot of uncharted new territory, and so I just wanted to focus on the code. There we go. Are you able to access the FLIR measured temperature? Yes, I am, Jim. I just don't show it at the moment, that's all. I didn't really, for the purpose of finding these shorts, I didn't really worry about showing what the actual centigrade temperature was, or the absolute temperature was. For me, it was all about the relative temperatures. But, as I said, with advancements of the software, when I add more onto it later, I will have that sort of data being added on top. But we've still got to work out how to do a heartbeat short. And I'm genuinely disappointed that it didn't work well. I'll try on that 3115 again. I'll just take the cap clean off and put the resistor straight down. Because I know I've definitely fixed a few like that. I suppose I should really repair this before I go any further. What's your methodology when it comes to calibration of sensors? None. I've done absolutely no calibration of this because it's all relative. I mean, I suppose I could do ice bath calibrations and all that, but as far as I know, the FLIR actually does a pretty good job of self-calibrating. Oops, scratch nose. So, is the heat map generated from the entire area covered by the crosshairs? Not sure what you mean, Tony. Basically, the sensor, the FLIR sensor, covers the entire window that you could see, the entire visual picture that you're able to see. And I was just simply squelching out all the information that I didn't really care to see, because when it comes to these shorts, then 99% of the time you're looking for the hottest spot. About the only time that doesn't always happen is when you're dealing with iPhones and it ends up that your VCC and VCC BAT MOSFET is the one that cooks up, but it's not actually the fault. And that's what we could do. We can get ourselves an iPhone. Come back here. Get ourselves an iPhone 6 and put a resistor on the Wi-Fi cap. That'll work. But again, it's not a heartbeat short, and that's really what I'm interested in right now. Sonia, I will not be porting it because, well, for one, there's already probably reasonable software for it on Windows, and secondly, I don't know how to do USB stuff under Windows. But for all the non-USB, if you can take the code that I've written and if you can take the code that I've written and sort out the USB connect and endpoint and data transfer side of it, then everything else should work fine for you, because this is written in SDL2 and of course it's cross-platform. Nick Custers, yes I am. Yeah, it's still the FLIR. Ask the FLIR company to donate a few thermal cameras so you can try and run thermal camera through the microscope. I was thinking I would love to be able to do that, but I'm not too sure because glass normally stops infrared. So it basically gets you nowhere. You would need to have a specific port made out of something like, I don't know, selenium type glass in order to be able to pick it up. Christian, yeah, libUSB, is that on Windows? I don't know. Anyway, look, the software is up there. Try compile it, see if it works for you. Loke, it's because I don't care. I really, unless it cross compiles just by itself, I really don't have the inclination to do that for Windows software. Like, there's nothing personal against Windows, it's just that is a big resistor compared to what we'll say. I just figure most of the time the software that people want already probably exists in Windows somewhere, and so me spending extra time on it, someone else can do that hard work. I figured I've already done the first bit. Someone else can do their bit and do the port. And of course when they submit a patch to me, I'll go, nah, I don't want it, just go run it as your own fork. I'm not a very approachable software person. When it comes to software, I'm too much of an artist. And believe me, artistic software coders are the worst to deal with. Because to be a good software coder, you really have to be a little more pragmatic about it, not get all upset when someone says, yeah, this code is broken here. Not have your little hissy fit or anything like that, just sort of go, yeah, okay, thanks, so I'll get that fixed, and move on with it. In fairness though, there is a certain degree of finesse that you can have that will greatly ease that process. Like if you're a person trying to submit a patch, then there's definitely ways that you can have a far greater success rate. Rather than, I think the worst is when people come in and say, your stupid software does this, or it's passive aggressive, or you get it so often. And you're like, take a walk off a plank. Because you just don't want to deal with people like that. But of course, it's one of those unfortunate scenarios where you become your own worst enemy and then people just start baiting you, and yeah. Well, Christian, if you look at the software code, it might be, it is using libUSB, so who knows, maybe it doesn't need porting, maybe it'll just work. Sell it to Lewis. Wait, but then they'd get the profit and not me. I don't know if I can stand for that. Yeah, the only thing that really grinds my gears with this is that it's GPL software. And of course, I also had to release it as GPL, and yeah, that was a hard thing for me to do. I'm not a fan of GPL. Nick Custers, how many paying users did your software have? A couple of hundred at the least now. I haven't really bothered to check, but yeah, there's certainly quite a few now. Personally, I'd like to see a few thousand. What is in you? Yeah, a few thousand would be nice. I'd actually own my house by then. Okay, obviously that board's still a bit warm from me. This is going to be kind of cheating if I heat it up, plug it up right now. Let me adjust the... It's a bit better. Mr. Mick, you'll be getting Flex Boardview soon? I would certainly be appreciating that, believe me. I appreciate it anytime anyone buys that software. Lets me get a house, lets me get on with other work, and indirectly or directly, take your choice, it allows me to write software like this. So it's a bit of a cyclic thing. Open source software lets me build tools that allow me to do a better commercial job, that allow me to then put my own money back into and time into writing other software packages. So it does end up helping all around. And of course my own commercial projects, I often release some libraries and things like that to help people doing other things. Probably the most popular package that I have that gets downloaded is a thing called RipMime, and it allows people to take an email file that comes from an email server and just split it into its various portions, attachments, body, headers, footers, things like that. And that's been out there now for well over 20 years, and goodness knows how many, there's well over 100,000 downloads now. And yeah, not a cent from it, obviously, although that's not true. I have had people contribute money from it. Alright, we're going to plug this board in, and hopefully we get a reaction. Okay, it's plugged in, it's not turned on. Turning it on. Oh, we found it, but it's not a heartbeater though, that's a constant one. Well, that just sucks eggs. Yeah, because that just comes up 770. Yeah, that's no heartbeat. That's flatline. No. Next job, find what's making the noise in the exhaust fan. And that's my fume hood. I am generally thinking of just buying one of those ones that Dave Jones reviewed recently, because yeah, $225, okay, let's say $500 landed in Australia. If the filters aren't too expensive, then I'll definitely be buying one. It's nice to have turnkey solutions for a lot of stuff. It's okay when you're younger and you've got plenty of time and you don't have other work to do. to mess around with these things, make your own contraptions and stuff. But when you really actually do have to get work done, then things like soldering irons, hot air stations, fume hoods, power supplies, you just want to buy something that works and leave it at that. But damn, I was really hoping that would be a heartbeater. I'm upset. Maybe I need to make it a stronger one. Maybe it's not enough to cause it to trip. I mean, that's obviously... Yeah. No, I drifted off. I do like this ability to look underneath the heat map and find exactly that part. So that's pretty cool. I'll definitely pat myself on the back for that one. Tie 555 to it. That'll make it clock and clock and clock. The good old 555. Poor man's microcontroller from the 1970s and 80s and 90s. Well, I'm going to try and put another resistor on there, another 33, and that will drop us down to 15 ohms. I can't seem to find any of my smaller ones. Yeah, let's get crazy and put 3 on there. And that'll give us 10 ohms. CMI, Harold, it's freestanding, this is. It's not attached to anything. This is just plugged into USB on my Linux computer, and that's it. Nothing else. And the nice thing is it doesn't require any video for Linux loopbacks or anything. It's just plug it in, run the software, it works. No hack jobbing, nothing. The biggest hack job here is me trying to find my flux. Well, fume hood's not doing so good at the moment because I took the vents, the ducting away from it. Because I'm an idiot, that's why. But yeah, seriously, if the price of the filters on that fume hood that Dave Jones reviewed are not too bad, I will definitely be ordering one. Don't get me wrong, I do like my setup, and it's worked well, but I kind of get sick of the fact that sometimes it falls apart, sometimes something gets sucked up in there. Then again, I suppose I'm going to lose the status of having the turbo cooler, so that could be a little unfortunate. I'll have to have a think about it. Yeah, Corey, is very similar to the Pace, isn't it? I mean, they're all basically going to be technically the same inside. So we just want to know what the damn filters are. Whoa. Going for a wild ride there, guys. A little too wild. Come on back. Let's try to fatten up the edges so we can get some more current flow up the side. Yep, I was worried that was going to happen. And the nice thing is, if you're only going to do it for a short time, this thing actually just runs off battery. It has a built-in battery, so this is just the USB going to the PC, and on the other side there's a USB-C for charging. But for the moment, I'm just running on battery. Kind of makes it a little bit easier. Alright, let's see if this pops and blows. Harold, one big reason for having filtering here is because during summer we want to keep the room cool. And if we just constantly pump air outside the window, we're never going to get cool. So it'll be really uncool to not be cool. Okay. Yeah, let's see if this exceeds what. Helps if you turn it on, Paul. Okay, now it's going to be interesting because we're actually sort of showing nothing. So maybe the resistance is just too low. Let me spray it down and see what happens. I think it's actually too low. Must be a critical balance between when it just stays completely shorted and when it heartbeats. Who would have thought that capacitors would have to be so precise? Ooh. No, it didn't have to be. It just need to be connected better. Something just smoked then. There may... Oh yeah, something's smoking there. Yeah, well that's definitely a very upset resistor now. Yeah, I'll have to look at what I can do about changing that sort of data. I'm not sure yet how to do it. I guess that's more things for the future. Well, we still haven't got a heartbeat scenario, and I'm not sure what I'm going to do about that. Maybe the heartbeat scenario is not that the circuit keeps retrying, but rather that the capacitor itself is the oscillating component. I don't know. As in, maybe what happens is the capacitor shorts, heats up, and it causes it to unshort itself. I don't know. Anyway, I better put the capacitor back on here. Yeah, Corey, I saw that it locked in on that spot. And unfortunately the problem was it just kept... Well, it just remained there, whereas I wanted it to pulse. Pernov, any idea what cap I can short to cause a heartbeat fault? Because I'm having no manner of luck whatsoever getting a heartbeat fault going right now, in spite of my best efforts. Seems to actually be a fine balance between shorted enough but not too shorted. I think we should try and put like an 80 ohm resistance down and see how that shows up. Because 80 ohms is certainly something that I see, maybe even 100. Cracker cap, yeah, it's probably just as unpredictable as what I'm doing right now. That's the trouble. I tried crack one, it was actually surprisingly difficult. Okay. Try trimmer pop. Yeah, it's possibly an idea. Maybe he just needs to put a chip in. Yeah. Yeah, I'm just. So we need to put on a rail that will constantly retry. Man, I just realised I've got to ultrasonic clean this now. Damn it. Maybe you could do something with the buck converter to get that oscillation you're looking for. Yeah, I suppose clay freefin, yeah. Or just simply something, I guess. I kind of want to see what percentage I can get down to, like maybe a 5% duty cycle, and see if it does the trick. Because that's one of the key things I want to look for on boards, is where you get what looks like only maybe a 80 milliamp draw on the power supply, but you know that it's peaking somewhere else, but it's not peaking high enough to really pick it out with your thumb. You'll have to go rifling through your bin, looking for a damaged cap. That's the unfortunate thing. Tried CPU V-Core. Oh, geez, Poundov, thought you were going to be useful today, but you're not. No, you're just not being useful whatsoever. Oh well, let's try to put 100 ohm. I'm gonna put it on the blimmin'. I'm gonna put it on this one that's got the problem with the Thunderbolt lanes. Yeah, call it now, that'll work. Yeah, I guess I'll just take this one here. This is why you should always keep your broken caps. Yeah, except we really don't want an L here. An L doesn't know how to do this with finesse. It's just I got a 1 ohm resistor, that's no good. What are you guys? 2.2 ohms, I'm really heading on the wrong side of the spectrum there. $250 ohms. Yeah. Okay, we could stick 250s on there. Nick, yeah, because this isn't actually a job. This is just me stuffing around. So there is no job. I'll be very surprised if this manages to dominate. Because I can't imagine this is going to inhibit the system from booting. That's the problem. We actually want to do something that inhibits the system from booting, but keeps it trying. So kind of gives you false hope, or gives the board false hope, but constantly takes it down. Hey, what the heck? Where did you come from, little screw? You look like a iPhone screen screw. Okay, I'm just looking for MagSafe 2 right now. Ah, there it is. Remove a good cap, place on the bench, hit with hammer. It'll probably be... Yes, Alec, we still are. Yep. Yeah, I kind of need those glasses. It'd be good if I didn't break them. Fortunately, the battery in this lasts about 40 to 50 minutes, so at this stage we haven't yet run out of power. Okay. Okay, here we go. This is pretty warm over here. We are getting something showing up, like around about here. But it's fighting with this. Alright, let's see if it shows the resistor. Yeah, it's showing the resistor there. I'd say that we're a little bit offset. The board, this is all hot here because of the... Okay, that's the alignment better. So, yeah. So it's showing the resistor up, so... Okay. Oops. There we go. But again, it's just a normal short. How boring. I'm not sure how I'm going to do the thing. So, well, that's pretty useful though, nonetheless, because that's 250 ohms. And that is not a hard short by any means. I could probably put my finger on that. Okay, it shouldn't burn too bad. I can actually keep my finger on that. So that's less than 50 degrees centigrade. I can see now I'm definitely going to have to put the temperature readout on this. I'll do that tonight. Yeah. So yeah, that's less temperature than human burn point, and it's picking it up and pinning it. And I moved the damn camera and cable. Shoot. Either that or it's running out of battery power. So that's good. That helps me a lot too, because that lets me know that then even with very light shorts, it's going to show them up. Yes, English Hedgehog, I've been working on my software. If I could just get away with this damn cable being such a pain in the butt. Yeah, no sizzle, I'm sorry. Let's try again. Yeah, definitely no sizzle at all. If I bring my hand down here, you can see even my hand is showing up as within the temperature range. So that's human temperature range, and it's picking it out over everything else. I'm really happy with that. Oops, I forgot. That's a feature. Spacebar. Spacebar lets me freeze frame. So, alright. Okay. Well, I still haven't got a heartbeat, and that is really the test that I was truly looking for. But I'm going to guess that given that we're picking up the heat signature from a 250 ohm resistor, and what's our voltage on that? We've got 8.5 again, I'm going to guess. You're not going to be able to see this because I haven't got it on screen, but yeah, 8.5 volts, 250 ohms. So someone want to work out how many watts that is? Can the FLIR charge through the USB-C slot, or is it separate? I'm not exactly sure, Tony, whether the USB-C data port will let you charge or not. It doesn't. I don't think it does, but I'll find out when I get my extension cable. I've got a Thunderbolt, genuine Thunderbolt 3 extension cable. I shouldn't say genuine. It's just it's a high grade one that should work with everything. If I'm lucky, it will charge through that, but as far as I can tell, maybe it does have to charge through this. Well, you can't see it; it's off screen, but charge through the second USB port. But certainly, with a few tweaks and stuff, I'm sure I'll. Yeah, I think definitely I'll bring the temperature up, mostly because a lot of people are asking for that sort of thing. Yeah, how hot it is it? And I'd say that's probably like 40, 45 degrees centigrade. Yeah. Hope you gave Jim Boardview software or something. If Jim actually did Boardview repairs, he absolutely can have a copy. I'll give Jim what I can. So, well, what is the time now? Yeah, it's 10 to midnight. It's probably time for me to go. I'm starting to like drift out now. So now is probably about the time for me to take this infrared camera into the other workshop or the administration room and do some more working on different features of the software. About 200 milliwatts of power. Thank you, Enrico. Appreciate that. Yeah, so 200 milliwatts across a 1206. So that's 3 by 2 millimeters, a 6 millimeter square area. Plus, it's also probably been drained very quickly by the board itself. So I'd say that's a pretty good, nicely sensitive. Yeah. So definitely, I'm happy with that. Yeah. All right, that's it. I'm out of here. I'm going to go do some coding to relax for the night. But maybe tomorrow, or maybe sooner or later, we'll get another heartbeat fault and it'll actually come to be useful. In the meantime, if you do want to have a look at the software, it is up on GitHub. If you just look up FLIR view, I couldn't call it FLIR view because for obvious reasons. Are you like to do any software streams? I keep meaning to do one. I've got to make a keyboard tester program, and I just keep running out of energy. What is that? Oh, it's my. I'll show you what it is. Come here, camera. Reveal the world. You're upside down. Don't blame me. It's my yeah. That's the ultrasonic cleaner. 22-liter ultrasonic cleaner. And that's why it's making all noises. It's sitting at 70 degrees at the moment, so it kind of wants me to turn it off and go to sleep. So, alright, I'm out of here. Thank you very much for watching. Sorry it wasn't quite as packed as I wanted for features and excitement in the stream, but sometimes that's just what reality is like. That's your lesson for the night. I'll see you all later. You'll take care.